Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, is that a shelf or a robot? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week we're returning to the topic of industrial robots with a guest whose remarkable robotics career led him to found Robust.AI, a company focused on producing intuitive and collaborative mobile robots for warehouses and factories. But first, I'm thrilled to officially launch the Robot Talk shop, where you can get your hands on some awesome Robot Talk merch, including t-shirts, stickers, and mugs. This has been a long time in the making, but I'm really excited to be able to share it with you today. This shop is part of a longer-term mission of mine to make Robot Talk financially sustainable, so that I can keep producing the podcast for years to come. By shopping in the Robot Talk store, not only can you get some really cool stuff, but you can also help to support the podcast. So please do check it out at robottalk.org/shop. I'll be expanding the selection of products over time, so if there's something you'd like to see there, get in touch. And a quick shout out to my new Patreon supporter, Toby. I can't thank you enough for supporting the podcast. Welcome to the Robot Talk community. So, with all that said, it's time for me to introduce this week's guest. I recently had a fascinating conversation with Anthony Jules from Robust.AI about their autonomous warehouse robots that work alongside humans. This week, I'm speaking to Anthony Jules, CEO and co-founder of Robust.AI, a robotics company focused on AI-driven warehouse automation. Hi, Anthony. Wonderful to have you on Robot Talk.
Hi, Claire. It's my pleasure to be on the podcast. Thank you so much.
So you started your career at MIT and since then have played a lead role in several different robotics companies and startups. So could you give us a little bit of an overview of your career path so far?
Certainly. I, as you mentioned, started at MIT, studied robotics and AI. And then, of course, my first job out of school was not either robotics or AI, but it was building large information systems for Fortune 500 companies at a company called Sapient Corporation. And we scaled that from 3 people when I started there to almost 4,000 by the time I left. So It was a pretty incredible experience of being part of a leadership team for a hyper-growth company. Went on from there to build video games at Activision for about 7 years. And that was incredible because it was really where I started to experience teams that were highly multidisciplinary. My first taste of that, of course, was at Sapient with the birth of the web, where for the first time you had designers and programmers and what we used to call webmasters back then, and roles that no one knew what to call, but they were content creators and marketers. And that was my first kind of dipping my toe into multidisciplinary teams. And then games at Activision really blew that open. And interestingly enough, it turned out that that was great preparation for jumping back into robotics, which I did almost a decade and a half ago, actually, because it takes an incredible number of disciplines to build a robot that's useful for people in the real world and interacts with them appropriately.
Yeah.
So from there, after Activision, I was one of the founders of Redwood Robotics. And then that got bought by Google. So then I was part of Google Robotics for about 4 years. And what I saw at Google in terms of modern AI was brilliant. It was a moment when very few people really understood what was happening with modern AI and deep learning.
Yeah.
It was that moment when ImageNet provided enough data for us to start getting incredible results. And it was at that moment that I was convinced that we now had one of the last pieces that we needed to build incredibly capable and cost-effective robots. So coming off of that, I then took about a year and a half studying on my own and writing business plans and coming up with lots of different ideas, which led to what I'm doing now, which is Robust.AI, where we're building collaborative mobile robots like Carter, our flagship, that work with people in real world environments.
Amazing. Yeah, what an incredible journey. I've been watching the developments in AI with real interest, but for me, the exciting part is where I think the term is where we embody that AI into a physical being that can move around the world and interact with things. So can you talk a little bit about what inspired you to found Robust AI?
Yeah, so my journey started at MIT, as I mentioned, and my co-founder is someone I met at MIT. He's much more famous than I am. So my co-founder is Rodney Brooks, who was the head of the AI lab when I was there at MIT. He went on to be co-founder of iRobot, co-inventor of the Roomba, and has put more robots into the world than anyone. And one of the things we sometimes say is, back then, 30 odd years ago, we built bugs because that's all we could build. He went on to build much more complicated robots, including many types of humanoids. My path, as I mentioned, took me through Google in the early part of the deep learning and modern AI boom. And it was that experience that really convinced me that deep learning and tools like that could bridge some of the gap that we need for robotics. One of the big holes, if you will, that existed before that was how robots could perceive the world and understand the world. And I'd say we're still not at the point of having real perception or real understanding the way that people experience it. But what robots do is a different thing. But it is a way of understanding the world semantically, being able to have some overlap with people and through cameras and through other sensing say, yes, that's a person, that's a chair, that's a pallet, that's a forklift. And by having that type of model of the world, it creates an extremely rich perspective to then program from and develop systems from.
Yeah.
Many people think that this, of course, is how all robots actually work. Stunningly, most robots are actually quite blind. We see these pictures of autonomous vehicles that have these giant, beautiful pictures of point clouds showing you everything in 3D. That's actually not what indoor robots use. They use typically a two-dimensional LiDAR, which gives you one slice through the world. So imagine if you're looking at the world through like the space between two boards, like this peeking out of your house with this little slot between two boards is really how most robots, most indoor mobile robots see the world. And we're at this moment when both from a cost perspective and from a capabilities perspective, we can now transition to using cameras instead of LiDAR and having robots actually understand the world around them in human terms. And it was really seeing the beginnings of that technology that convinced me that we could build robots that were truly interactive and could interact with people appropriately.
And so why did you feel that the kind of warehouse automation sector was the right place to apply this technology?
So a couple of reasons. Like many companies that were started in late 2019 or early 2020, the first couple of years of our experience became the COVID experience. So that colored, I think, our journey like it did any company that was started around that time. And I think a few things happened. The customers that we initially intended were no longer accessible because of COVID. So it allowed us to look at use cases across many, many industries. And what we saw was an incredible need for human-centered automation in a number of industries, and through what I call product management 101, trying to understand pain points, trying to understand what value you can bring to what markets, just very broadly, or what holes exist. The logistics and supply chain sector kept rising to the top as we looked at many different industries. And what we kept hearing as we talked to customers, because that's, as I said, I'm a product person, so I can approach everything as what I call product management 101, find an actual need and then build something that solves it.
Yeah.
So in having many of those customer conversations, what really emerged was a huge need for automation that increased productivity. Behind closed doors, no one actually believed that we were going to or were capable of automating all of the people out. And in most cases, people actually don't think that is compelling or the correct objective, because people provide a very different set of validation and quality checks than automation can provide.
Yeah.
So that combination of people providing oversight, people providing context, and automation doing what is dull, dirty, dangerous, highly repetitive, that combination is one that's extremely powerful. So the message we heard from people is, what we need is automation. We absolutely have a labor problem, but solve it in a way that increases productivity of the labor that we want to and are capable of retaining. And that ends up being a win-win for everyone.
Yeah.
So you're really off the back of that research and customer discovery, we developed this idea of Carter, which is a fully autonomous mobile robot that's also truly collaborative. And it really comes to kind of one of our core beliefs is that robots should empower people. And it's not just about replacing people everywhere.
Yeah, absolutely. So tell me more about Carter. What does Carter look like? How does Carter work? I want to hear it all.
Yeah, so Carter is a fully autonomous, collaborative mobile robot that's built for warehouses and manufacturing environments. It is revolutionary in a few ways. One is it only uses cameras. It doesn't use LiDAR. It has a semantic understanding of what's around it. So Carter knows when a person is nearby. It knows what a shelf looks like. It knows what a pallet looks like. And it uses those things in how it navigates and what it does. And I think what surprises people the most when they see Carter is it looks like a shelf. So it's very approachable form factor. It looks like, a shelf or a cart that people use already. I think if you spend any time in a warehouse, you will see, depending on the size of the warehouse, somewhere between 20 and 400 carts.
Yeah.
So it looks very familiar. And it even has a handle that you can grab onto. And when you grab onto that handle, we do some magic in the controls and AI to make all of the mass disappear. So you can now move this thing that's 100 to 300 kilos in total mass.
Wow.
And it feels completely weightless. And what that does is it provides a very approachable form factor, something that's very easy for people to understand. It gives people agency at all times. So if someone on the floor knows the right thing, they literally grab the robot and move it to the right place. And it provides incredible utility by driving stuff around and moving payloads around constantly. So it looks like a cart or a shelf that people are accustomed to, and they just drive themselves around when they don't need anyone to do anything with them. So it's this whimsical, in a way, but incredibly functional and practical take on robotics, where people find it very approachable and appreciate the functionality. So what we find is an incredibly high level of user excitement and support from people in the field. The other thing that I want to mention about Carter that's just really fun is, I mentioned kind of how it allows people to have agency.
Mm-hmm.
And one of my favorite examples of that is, I was at a customer site just observing what's going on. And 3 robots are lined up because orders have been picked onto them, and now it's time for them to be unpacked and those to go into packing.
Mm-hmm.
And the floor supervisor decides that the 3rd one in line has high priority items on it.
Okay.
Instead of having to find the special laptop or the little tablet and move stuff around in a queue or do any of that operational bric-a-brac, he grabs the handle of the 3rd one, pulls it out of line, moves it to the front of the line, and sticks it in and tells the person who's unloading, unload this one first, and goes about his business. It's not something we trained. It's not something we expressly said, this is how you change priorities. It's just because it's a natural way to interact, and it has this very close analog to actual things in the physical world.
Yeah.
Allowed him to reprioritize a queue of work tasks simply by moving something physical in the real world the same way that feels intuitive and feels natural for us. And it was one of those moments when I didn't say anything, but I was just sitting there with a huge smile on my face and delight, because it was a moment where it says all of these tiny little decisions we've made to design this thing that in some ways disappears is working. Yeah. We just allowed someone to prioritize a work queue in 3 seconds without having to kind of get their head out of their work environment.
Yeah. Yeah, that's a very compelling example. So you mentioned that Carter has like a semantic understanding of the environment. I've interviewed all kinds of roboticists on the podcast over the years. And one of the topics that we've covered a bit is kind of the challenges of doing that sort of thing in like a home environment where things change, things are radically different from one place to another. Warehouses are a little bit more uniform than that, thankfully. But how much is Carter able to learn on the job versus kind of just being able to apply its existing knowledge to an environment that kind of more or less looks the same in every warehouse around the world?
Our scheme for learning with Carter involves what we call human in the loop. And I think at this stage, it's actually important to think of what the fleet and not just the robot.
Yeah.
So what we care about and what we focus on is learning at the fleet level. So there are little things that each individual Carter will do. It will see new features. It will see that objects are in different locations in a warehouse. But then that individual Carter actually shares that perception of what it's seen, that map that it has encountered, with a shared cloud environment that all of the Carters in that same fleet have access to. So for every facility, we have essentially a lightweight digital twin of that facility, which is the aggregate of what all of the Carters in that facility have seen and have reported.
Okay.
And that allows kind of a first step of immediate responsiveness, or what I call panoptics. Any Carter knows what's in all the aisles that it can't see if there are other Carters in those aisles. But then in terms of how Carters learn and evolve over time, we actually do that with offline training and then pushes back out to the fleet. And the reason for that is 100% driven by maintaining quality and maintaining performance on live customer sites. The idea of a single robot learning from examples in situ is romantic, but it's not actually what our customers are paying us for. They're paying us for increases in productivity and a flawless user experience for their floor associates. So, for example, we've publicly shared that one of our DHL deployments shows a 60% productivity increase over what they were doing previously. And this is on the back of the fact that DHL is the number one operator in the space. So we're starting from a pretty high basis.
Yeah.
That's what they're buying. And the interesting thing is that's even what the floor associates are buying. Some of our research, which is pretty pivotal to how we've designed it, was getting at the floor associate experience. What do you define as a good day? And their definition of a good day isn't more coffee breaks. It's all of my tools worked. I was able to hit my numbers or maybe even go past my numbers and in some places get my $2 an hour bonus. Not all places have that. That's the contract, if you will, of everyone in a facility. We're all working to be as productive as we can be. And that's actually what gives people a sense of satisfaction and the other rewards. So because we have to live up to that promise, we don't do things that are unpredictable. But we have this tremendous ability to constantly train and make Carter's AI models better, make Carter's navigation better, and make Carter more adaptive as the facility changes because stuff moves around in facilities. And essentially we do all of that offline. We retest it offline before we push it back to any fleet at any customer's facility.
Mm-hmm. Yeah, there's nothing more frustrating than trying to do your job and the tools don't work. So I think that's a very, very wise model. So I'm really interested in this point you mentioned about all of the Carters kind of sharing knowledge, kind of almost like a hive mind. Do you kind of consider Carter to be part of a swarm?
Absolutely. So if you come up with better ways to talk about it, I would love it, because I think when we say hive mind, people think, oh, the Borg is coming. But Carter is an extremely interactive robot. It's a robot that's made to work seamlessly and safely around people. And because of that, I think it's critical to define the interaction model and to have some priors around, call it the archetypes of that interaction. The best one that we've come up with so far is Carter's kind of like a hunting dog.
Okay.
By working with its person, they both accomplish things that they can't accomplish alone. What Carter gives its person is capabilities that the person doesn't have, senses that the person doesn't have. There's a kind of semi-alien companionship that they share, but they both appreciate each other's capabilities. One of the places, though, that this metaphor breaks down is this idea of panoptics, this idea of fleet learning. So in addition to having these lovely qualities like, you're pushing Carter and it slows down because it knows that a forklift that's not visible yet is coming down the lane right in front of you. Because Carters have this broad sense of the warehouse, they have these senses that people don't have. So, I don't know what the right way to describe it is, but fleet learning as a paradigm is one of the most powerful ideas and capabilities that I think current and future robots will really bring to us. Because anything that one robot experiences or any data that one robot collects can be turned around and used to, as I mentioned, train AI models or add features to your VSLAM map or whatever it is. And then all of the robots get the benefit of that. Some of those learnings even transcend a particular fleet. So you can imagine a person detection model getting better and better and better based on not just what we see at one site, but what we see across all sites. So there's this incredibly powerful flywheel that fleet learning affords us. Yeah,
that's really cool. Really exciting kind of future potential for that. So what is next for Robust.AI? What new projects or innovations are you particularly excited about for the next 5 years?
So our first one, of course, is just scaling Carter and scaling our business, deepening our deployments with global leaders like DHL and continuing to add more and more capabilities to Carter as we expand. Maybe one of the final things that I'll mention about Carter is because it is this flexible platform. It uses cameras to see what's around it. It has a semantic understanding of its environment. It's very interactive with people. It, of course, has a screen and these things called marquees that give people cues and information about the context of the job that's being done.
Mm-hmm.
We think of it as a flexible piece of movable infrastructure so that it can lead a person to a thing that needs to get done or meet a person near a thing that needs to get done and give them instructions about that thing, and then bring tools or supplies to them and then take tools or supplies away, depending on what the job is. So one of the things that we're most excited about is expanding on that. We really see this moment in robotics being when robots are more like smartphones than flip phones. Some of the robots that exist now, including Carter, are software-defined infrastructure. They can become different things purely from software, depending on what workflow you want them to do or what program you have running on them, essentially. So that's a huge area of expansion for us, which is just adding more and more software features and scaling what Carter does and the workflows it can execute and the environments in which it can execute. And I think this is part of a broader trend of physical AI and embodied AI, which is really, we're at the beginning stages of defining this new category of how humans and robots share space safely and what the rules of that interaction are. We think the rules of the interaction should be, of course, people are always safe. People have agency over robots, and people are empowered by robots when a person and a robot or a person and a system of robots are sharing tasks and sharing space. And I think that that's an incredibly important principle as we scale up the number of robots in the world and the number of places where robots are doing activities in environments with people and therefore going to interact with those people. And I think it's something that you can't design after the fact. You have to design, ahead of the need in a way. It's almost like designing clothes after you need them. Would not be very useful.
Yeah, absolutely. I like the kind of the image you're painting in my mind of like essentially robot teammates, working together with humans, but not taking over from them, just being there when they need them and kind of anticipating what is needed.
Absolutely. We have this term that we sometimes like to use, which isn't modern English as much anymore, but this idea of being ready at hand. And the idea is that Carter should be ready at hand for people that it works with. When you need the thing, you literally stretch out your hand and Carter is there for you to interact with it or present you with the thing that you need. And then when you don't need it, it almost disappears.
Yeah.
And if we can get there, then we've hit our design goals.
Yeah. Anthony, it's been great chatting to you today. I've been talking to Anthony Jules from Robust.AI. Thank you.
Thank you, Claire. It's been a pleasure.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. And check out @Robot Talk Pod on social media to see a photo of Robust.AI's flagship robot, Carter. Next week, I'm talking to Heather Knight from Oregon State University about creating sociable robot collaborators. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.